So, how you doing? This is Professor Parker with all this math, and today we're going to multiply some polynomials. We have two examples up here. We're going to knock these out, and then that'll be it for today. But again, these are some fundamental skills that we should have in algebra, or in our algebra regimen, right? So the first example, let's talk about that. We have a monomial with the prefix mono, which means one, right? Because this is essentially one term, all right? Even though if you unpack 2x to the fourth power, you might look at that as saying, well, the 2 is a term and the x to the fourth is a term, which is true. But when you combine them through multiplication, they become one term, all right? So we think of 2x to the fourth as one term. Now, when we have multiple terms, terms are separated by plus signs and minus signs, all right? So that's why this right here is called a binomial. It's a binomial because it has two terms. The 3x is considered one term, and this negative 3 is considered one term, right? So we have a 3x and a negative 3. They're separated by a negative sign. So this will be a binomial. Now, if you remember, when we have a term written outside of a pair of parentheses or a parenthesis, and there's no sign in between that term and the parenthesis, then we know that we have to do multiplication. So this means that we need to multiply this 2x to the fourth by everything inside the parentheses. Everything. All right? So I'm going to draw some lines, and I think you should do this too. I recommend drawing lines from the outside term to each of the inside terms. Because the first thing I'm going to do is I'm going to multiply 2x to the fourth by 3x. And then I'm also going to multiply 2x to the fourth by negative 3. So a mistake that a lot of people make is they will only multiply 2x to the fourth by the first term, in this case the 3x. And they forget to multiply the 2x to the fourth by the negative 3. You can't forget to do that. You have to multiply the outside term by everything inside the parentheses. You can't leave anything out. All right. Now, what I'm going to do is some people do this with mental math, but I'm going to actually show all the steps. So what we're going to do first is this. 2x to the fourth times 3x. And then we're going to figure out what that's equal to. What product does that part make? So what you should do is this. First you look for coefficients, okay? The coefficients are the big numbers. So we got a 2 and we got a 3. You multiply those together first. So you multiply the 2 by the 3. And that product is 6. And then you look for variables that are the same, right? They don't have to be like terms. They don't have to have the same exponent. You can still do multiplication and division if your exponents are different. You can't add or subtract if your exponents are different, but you can multiply and divide if your exponents are different. So I have x to the fourth times x. Now, if we know our exponent rules, we know that when we multiply, we know that we take our exponents and we add them together. So you should say, okay, I'm doing x to the fourth power plus, wait, this x appears to not have an exponent because you don't see any exponent written right here, right? But dig this though. Whenever there's no exponent written, it's understood that there's an invisible 1 there. Because x is the same thing as x to the first power. So if x is the same thing as x to the first power, and that's something that you should memorize if you haven't already, just know that this x by itself, as it was written right here, it had an exponent of 1. So what you're actually doing is you write the x one time, and you're doing 4 plus 1 for your exponent, which is going to give you, we already got the 6 from 2 times 3, and now we're going to do 4 plus 1. So we have 6x to the fifth. All right? So that's the product when we multiply the outside term by the first term in the parentheses. But then we have to multiply the outside term by the second term in the parentheses. So that gives me 2x to the fourth times negative 3. Now, this is a little different because this negative 3 doesn't have an x term. But you still will look at the coefficients. So this 2 is a coefficient. this 3, the way this is written, this -3, it's not actually a coefficient. It's just a constant. But you also multiply coefficients by constants. So 2 gets multiplied by -3. It doesn't give us +6 this time. It gives us -6 because a positive times a negative gives you a negative. So that's going to give me -6. This multiplied by that. But then you should be wondering, well, what I'm going to do with the x to the 4th? In that situation, what you do is you just write x to the 4th next to the -6. It's part of the product. So again, you just take the x to the 4th and write it next to the -6. It's just part of the product. All right? So now, these are 2 terms that we end up with. So now all we have to do is just basically write this in a neater form, in a simplified form, horizontally. We write the first term and the second term. So our answer is going to be 6x to the 5th minus 6x to the 4th. Now, if these were like terms, we could combine them into one term. But they're not. They're not like terms because even though they're both x's, they have different exponents. Now, remember what I said earlier. The terms don't have to be the same in order for you to multiply or divide. But if you want to add or subtract, your terms have to be the same. They have to be absolutely the same with the same exponents. That's what I meant to say. Your exponents have to be the same. So this is a 5 and this is a 4. So you can't subtract those terms. All right? So this is our final answer. 6x to the 5th minus 6x to the 4th. And actually, this distribution is actually the opposite of, it's the opposite of division. Right? Now, also, you might say it's the opposite of factoring, but you use division to factor when you have a greatest common factor. Because this could be looked at as factored form of an expression, where the 2x to the 4th will be considered a greatest common factor. Now, when you multiply this out and you get this, now this expression is not in factored form. But if I was going to factor this, I would pick out my greatest common factor, which would be 2x to the 4th, and then I would divide each of these by 2x to the 4th to get 3x minus 3. I'll do another live about factoring at another time. But right now, I just want to drop that on you just to kind of like plant that seed if you're not as familiar with factoring yet. Because factoring is another thing that we have to be familiar with if we want to win in algebra. We got to know how to factor. And we have to know all the different types of factoring as well. So now let's look at number 2. Number 2 is a little different. Observe how number 2 is different from number 1. Number 1 has a term outside. Number 2 has a term outside. Number 1 has an expression inside parentheses. Number 2 has an expression inside parentheses. But the difference is that number 1 had a binomial inside parentheses. And in number 2, you have what's called a trinomial inside parentheses. And it's called a trinomial because you have 1, 2, 3 terms. 3 terms, trinomial. Just like a tricycle has 3 wheels. It's the same exact concept. All right? But we're going to do the same thing. We just have to do it one more time. Because here we had a binomial, so we had to do multiplication twice because we had 2 terms to multiply by. Here we have 3 terms to multiply by, so we have to do multiplication 3 times. So let's get to it. So we have 5k squared times the first term, 6k squared. And we're going to figure out what that product is. Now, what I told you, multiply the coefficients first. The coefficients are the big numbers. This 5 and this 6. They get multiplied first. So you do your 5 times 6. And if you know your multiplication facts, you know that 5 times 6 is 30. Then you're going to multiply your variables. So you got a k squared and a k squared. K squared times k squared. Exponent rules say that if the variables are the same, you write the variable one time and you take the exponents and you add them together. And that sum of the exponents is going to be your new exponent. So you take this k, you write it one time next to the 30, and then you add 2 plus 2. 2 plus 2 is 4. So that's going to be 30k to the 4th power. So 30k to the 4th power is the product of 5k squared and 6k squared. So now you've already multiplied the outside term by the first term. So now we got to do this 2 more times because we got to multiply by 8k and we got to multiply by 6. All right? So now we do 5k squared times, boom, 8k. So now we got 5 times 8. Remember, we multiply coefficients first. 5 times 8 gives me 40. And then we have k's again. We got k squared times k. And we add the exponents. So this k has a 2. This k has no exponent written. So again, remember, when there's no exponent written, that means that the exponent is an invisible 1, or it's understood to be 1. So this is not 2 plus 0. A lot of people make that mistake. They think that if an exponent is not written, then the exponent is actually 0. It's not. The exponent is 1. Exponent is 1. Because it's a k there. It's k to the first power. So 2 plus 1 is 3. So I have 40k to the third is the product of 5k squared and 8k. Now I got to do this one more time. I got to multiply 5k squared by 6. So we got 5k squared times 6. Now, coefficient gets multiplied by the constant. This is not a coefficient in this written form. It's a constant. But coefficients get multiplied by constants. So you're doing 5 times 6, just like we did 5 times 6 up here. And we get 30. Now we have a k squared in the first term. There's no other term or a k term or any other term next to the 6. So you just take the k squared and just write it next to the 30. So now I have my 3 products from my 3 multiplication problems. 5k squared times 6k squared. 5k squared times 8k. 5k squared times 6. And in order to do this, you have to know the exponent rules. That's key. You have to know the exponent rules. We'll do some subsequent videos about strictly exponent rules and how to use those. But hopefully you know the exponent rules in order to do this type of multiplication. And it'll come in handy with the division as well when we do division problems. So let's take this, write it out nice and neat. 30k to the fourth. We usually write the term with the biggest exponent first. That's what we usually do, right? So this will go in descending order by exponents. K to the fourth, k to the third, and k to the second. Plus 40, k to the third. Plus 30, k to the second. None of these are like terms. They're all k's, but all the exponents are different. So that means they can't be added together. They could be multiplied together, but we're not multiplying. We have plus signs in between. All right? So this is our final answer. 30k to the fourth plus 40k to the third plus 30k squared. And again, we're using a distributive property. Remember, when we distribute, don't forget to multiply the outside term by every term inside. Some people make the mistake. They multiply by the first term and leave out the other 2 terms. Or they multiply by the first 2 terms and leave out the last term. People are notorious for doing that. Don't fall into that trap. All right? Make sure you multiply the outside term by everything. It's called the distributive property. Make sure you distribute that outside term to everything inside, to everybody, right? We're trying to be fair. We're trying to distribute to everybody, right? We're not trying to be unfair and leave some people out, all right? Like in certain economic systems that leave people out. We want to distribute to everybody. We'll make sure everybody eats, okay? All right, also we need to understand exponent rules. And what else did I want to say about these problems? I want to say that it's important to show all your work and be organized in showing your work, but you'll get to the point where this will become mental math, right? I only showed this step written out just so you'll know, you'll be able to visually see what I'm talking about. But typically, you'll start to do this as mental math. You'll just do, boom, 2 times 3 equal sign, you'll write 6, x to the 4th times x, x to the 5th, boom. You'll get into that habit. But right now, I just wanted to show the steps visually so that you will be aware of what's going on and what I'm actually speaking about. All right, before I go, I definitely want to shout out Cheney University. Depending upon who you ask, they will say, some people say Cheney University was the first historically black college or university. Depending upon who you ask, some people say Lincoln University, where I earned my master's degree in educational leadership from. They'll say that was the first historically black college. Some people will say that Wilberforce University, where Du Bois taught at one point, out in Ohio. They'll say that was the first HBCU. I believe that they're all right because there are different criteria that they use to judge the first institution, right? I'm going to let them argue about that. It's not that deep to me. But yeah, I currently teach at Cheney University, and I really appreciate the opportunity to support historically black colleges in that way by actually putting in work on that campus. Not right now because of COVID-19, we're doing online classes, but the work is still being done. So again, support historically black colleges and universities. Tell a friend to tell a friend. Tell somebody about a historically black college and university. Research them, learn more about them, and just offer your support to those institutions. All right. So this was today's lesson on multiplying polynomials. I hope you learned something. And again, we'll be doing this every day, Monday through Friday, at least for right now. Based on depending on the demand, it might increase. We might go into the weekends too. But right now, we're doing Monday through Friday at 6 p.m. We're doing IG live videos. We are trying to fulfill the need right now. We are going to be going over math problems that people send in to the All This Math DM. So take a picture of your problems, send them in, and as long as if time permits, we'll get to your problem, and your problem may be on this board. All right. Thanks for tuning in. Hope you learned something. Peace.